Hey guys, it's Marcus. I'm going to be talking about probability today, just giving an introduction, revising previous concepts you've probably learned in previous years, and explaining important terminology. Now, so what is probability? So it's really just the likelihood of an event or outcome occurring. So it's in everyday life, from the weatherman saying there's 20% chance of rain tomorrow, to a football game, what's the percentage chance, or what's the chance that this team's going to win. It's all around us. And that's one of the great things I find with probability and throughout this chapter, is that even when the concepts and the way you have to calculate things become difficult and you have to use formulas, it still all relates back to real life. And a typical exam style question is going to be worded, try to have a real life context, because examiners like doing that in exams. Rather than just having some number crunching, they prefer to give you an application which you then have to solve. So now there's three ways we can talk about probability. Now, in the life context, people, and in everyday conversation, people normally use percentages. So 30%, 40%, etc. However, what we are going to use mainly in maths are decimals and fractions. But they're the same. So 0.3 is the same as 30%, 0.4 is the same as 40%, and then you can have fractions as well, ranging from 0 to 1. So let's say 3 on 10, 4 on 10, which simplifies down to 2 on 5, and so on. So what this means is we mainly use decimals, and that's because it's easier for calculations. And the decimals can range from 0 to 1. So you can have the probability of an event occurring could be 0. So if you're rolling a dice, then the chance that the dice will be 8. Well, obviously it can't be 8 because the numbers are 1 to 6, so it'd be 0. The chance that an event occurring for a dice roll, either it be the numbers between 1 and 6, well, they're the only numbers, so it's going to be 1. So this gives us a really important rule of probability, that the probability of an event, so I'm just calling them A and B by the way, has to be between 1 and 0, but it can also equal 1 and 0. So what we need to do, as you've learned in previous chapters, is we need to put these equality signs as well. So that means the event can be bigger or equal to 0, or smaller or equal to 1. And so whether it's a subset or a whole set, I'll explain this terminology in a few minutes, it always follows this rule. So this is a really important one to note. So going on to some phrases and terms that they use, and I've just been using the last few minutes, so subsets, sets. So what this is, this means the set or the sample space. And for whatever you're talking about, the probability, this means all the outcomes, all of those combined. So if it was a dice roll, then the set, the sample space would be 1, 2, 3, 4, 5, 6. These are typically used for Venn diagrams, smaller probabilities where there's only a few discrete numbers. However, it's important to note. Now, what you can have is you can then have a subset. So an event is a subset of the sample space. So literally just an event is one outcome or a few outcomes occurring. So if you wanted to work out the probability that a dice roll of all even numbers, so an event could be all even numbers, and that would be 2, 4, and 6. So that would be an event, because it is a subset, so it is part of the set, which as I said is the sample space or all the numbers combined, and you can work out the probability for that, which if logically would be 50% or 0.5, because 3 out of a possible 6 are there. Another quick note is that throughout my videos I may use this expression, and so that's a capital N with a small u underlined, and that's just a shorthand for numbers. so all even numbers. Now, another two terms, you've probably heard of them last year, but union and intersection, or even before then, especially in Venn diagrams. So union is this symbol, and intersection is this symbol. Now I have trouble remembering them, so what I think is that for union, all the numbers are going into this little space here. So I'll just do that in a different color. All the numbers are going in here, or you can also remember U for union, and then the intersection is different, so it's only a few numbers. And that will make a bit more sense when I explain the definition of both. So I like to think of union as and intersection as both. So if you remember, like intersection on the road, the street's going either way, it's where they both cross. And union, just you have to remember, it's both. So let's take a dice. So dice is a pretty typical example that we use in probability. So we're using a dice roll. So I'm going to say the sample A. So A is a subset, and so A is going to include 1 and 2. So when you roll a dice, you can get a 1, 2, but you could also get the other numbers. B is going to include 2 and 3. And so there's two different ones we have here. We have the A union B and A intersection B. So A union B would be 1, 2, and 3. So it includes all the numbers that are encompassed in both A and B. However, A intersection B would just equal 2. So, yeah, it would just equal 2. So for the intersection, it has to be encompassed in both A and B. It has to be in both. And so these are really important because you then use them in later probabilities, such as conditional probability, which we'll talk about in a few lessons. Now, there are two important sort of variables that we'll talk about in probability, and it's really important to distinguish and make sure you understand the difference between them both. So the first are discrete variables. And the others are continuous. And the names don't trick you. They're similar to what the names suggest. So for continuous variables, they have to be measured, as in they can lie on a continuous spectrum. Rather discrete, so discrete means particular numbers. They can be counted. So counting is an interesting way. It's best with an example. So discrete variable, an example could be goals scored. You could have 1 goal scored, 2, 3, 4, no goal scored, etc. But you can't have 1.2 goals. You can't have 2.5. Whereas continuous variables, let's say height. Somebody's height is, for example, 1.912334 meters. Of course, you would normally round and say that person's probably 191 centimeters or 1.91 meters, but technically for height it is continuous. It is not a discrete number rather that's being measured. So an important distinction with these is you have to think about, are they being rounded or is it continuous or discrete? Now it's important, it seems a bit arbitrary why we'd have to care about which one it is, but with later probability, some of the methods we use are only for continuous or only for discrete. So in a worded question, you have to be able to differentiate. So that was an introduction to probability. I'll next talk about Venn diagrams and going over how to do those. Thanks for watching, guys. Have a good day, and I'll see you next time.